Okay, welcome back. We are today going to do some circuit stuff. We're going to show how resistors add up in parallel and series, and then we'll form a circuit with three resistors. So in the theory class, okay, so let's take resistors here. Let's first measure what their actual value is. Right now, I'm going to take a resistor. This is called a resistance substitution box. I'm going to put it at 100, okay, and measure its actual value using the ohm meter. You take this here, you put this here, okay, you connect here, okay, so right now it's showing 102.1 or 102.2 ohms. So we have R1 is 102.2 ohms. So let's take two of them first of all and put them in series. What we're going to do is I'm going to use the multimeter as an ohm meter, and I'm just simply going to connect the ohm meter across the R1. From R1, I'm going to connect it to R2, and then back and complete the circuit. So let's see what the total resistance is if I have R1 and R2 in series. So you go from the ohm meter to this resistor, from this resistor to this resistor, and then actually I don't even need another wire. I could just connect this one to the other end of the resistor. You see, I have now made it in series. You go from here to here, from here to here, here to here, and now I measure the total resistance, 174.1, 174.0, something like that. Okay, so let's say 174.0. And theoretically, the total resistance should be the sum of the two. Okay, so now we have 102.2 plus 71.1, 173.3. So the total resistance according to that is 173.3. We have it a little bit more, so we're in the ballpark. Remember that the wires that we're using to connect also have some resistance, so that's going to play a role in affecting the result, but you can see here that the total resistance added up. Okay, so what would happen if I have them in parallel? Okay, so let's do that construction. For parallel, what you're going to do, you're going to go from this multimeter, you're going to go here, and you're going to complete the circuit using just one resistor, and you're going to take the other resistor and hitch it on top of this resistor. Okay? For resistors, these red and black doesn't mean anything. They don't have an inherent red or black. So I could have gone from black to red or red to red. That doesn't mean anything. So you can now go from this black to this black. So now I'm in parallel. Let's measure the total resistance. Let's say 42.2, let's say. So I went the ohm meter, and I get 42.2 for the total resistance. Okay. How about the theoretical? Well, the theoretical, you got to do 1 over the reciprocals. 1 over our total is 1 over 102.2 plus 1 over 71.1. So what you got to do with the calculator is reciprocate both of them. and then add the reciprocals. And you're going to get some answer like 0.0238, so on, so on, so on. But that's 1 over R total. And then you reciprocate that answer to get the total resistance. So you reciprocate that. You get 41.9 ohms. And our answer is a little bit more than that because of connecting wires. So you can see it really does work out that the resistance, when you add them in parallel, the resistances drop. Okay? When you add them in series, the resistance increases. Okay, how about more than 2 resistors? Okay? How about if we had the ohm meter, and then we had it R1, R2, R3. These two are in parallel to each other, so we have to combine them in parallel. Then that one is in series with that. Okay, so let's see what we get here. We have, the way to connect this is you would go here, you would connect to R1, from R1 to R2, R2 back there, make a complete circuit using R1 and R2, then connect R3 across R2. Okay, so you go from the ohm meter to here. This was R1. You connect this to R2. From R2 you go, you connect it, well actually we could just use it like this, back to the, this becomes like the first circuit we did, where they were just in series, right? But now, you can take R3, and you connect that in series, in parallel with R2, so all you do is you just take this wire and you connect it here, and then from here you connect it. I could just clip it onto this one. Actually, I could just clip it here on the top, right there. Okay, let's see what the resistance is. Okay, around 127.5, let's say. 127.5 or 0.4. Okay, so our total is 127.5 ohms. So let's practice this. Add these two in parallel. 1 over, we can call that 1 over R prime. 1 over R2 plus 1 over R3. So it'll be 1 over 71.1. Plus 1 over 40.7 you get 25.8 25.88. Then that one is going to be in series with R1, so you add R1 to that. Okay, just simply add it. So our total is going to be 102.2 plus 25.88, 128.08. And you see that's what we got. Okay. Is there a different combination we could do? Yeah, probably. You could change some things around. You could do. You could bring R1 here, R3 here. You could do this way. Okay, so you could go resistor goes to R1, goes to R2, comes back. Okay, the ohm meter makes a complete circle. R3 goes across both of them. So how is that different? Okay. Let me take out the... So this part looks the same. They're still in series. But this time R3 has to go to this end of R1. And then it has to go across this end of R2. So the R3 has to go, this end of R2 is this one that's going back to the ohm meter. And then this one has to go to which end? It has to go to the opposite end of R1 that's coming from the ohm meter. So it's going to go to the red one here. Okay. Now I'm going to get 33.3. Okay. So how is that different? Well, what we have to do here is add these first in series, and then that's in parallel with that. So the sum of the R1 and R2 together, these one is going to make the sum which we had done earlier, 173.3. And now you're going to do that is in parallel with this. So 1 over R total and then you're going to get from there our total is 32.96. Perfect, we got the same answer. So now you can see how we can analyze circuits using resistors and ohm meter. We can put them in parallel, series, and different kinds of combinations. Thank you.